Hi class. In this video we learn rule number 2 in the basic rules of anti-differentiation. And rule number 2 is on page 70 of your note packet and has to deal with the power rule. So just as there's the power rule of differentiation, there's the power rule of anti-differentiation. So at the top of your top of page 70 of your note packet in the rectangle, we write out the definition of rule 2, the power rule. If n, right, is any real number not equal to -1, -1 is a special case. If n is any real number not equal to -1, then the antiderivative of the power function x to the n with respect to x, how we find that antiderivative? We add 1 to the exponent and get n plus 1. And then we divide by the new exponent. So x to the n, antiderivative x to the n with respect to x is equal to x to the n plus 1 power divided by the new exponent n plus 1. And then we add to that an arbitrary constant c. And x to the n plus 1 over n plus 1 can be written as 1 over n plus 1 as a fraction times x to the n plus 1 power plus the arbitrary constant c. So in the first example, example 1 on page 70, we got to find the antiderivative of x squared with respect to x. Well, n equals 2 in this case. And so the antiderivative of x squared, we add 1 to the exponent and get 3. And then we divide by the new exponent 3. And then we add to that c. So the antiderivative of x squared is x cubed over 3 plus c, which can be written as 1/3 times x cubed plus c. In example 2, we're going to find the antiderivative of x cubed with respect to x. Well, n is equal to 3 in this case. And so the antiderivative of x cubed is x to the 4th, right? We add 1 to the exponent and then divide by 4. And we have x to the 4th divided by 4. Plus the constant c. And this can be written as 1/4 times x to the 4th plus c. So the antiderivative of x cubed, add 1 to the exponent, divide by the new exponent, we get antiderivative of x cubed with respect to x is 1/4 times x to the 4th plus c. In example 3, more of the same. In example 3, we got to find the antiderivative of x to the 99th power. With respect to x, right? So n is equal to 99 in this case. And so the antiderivative of x to the 99th is you add 1 to the exponent and you get 100. And then you divide by the new exponent 100. And then you add c. And this can be written as 1/100th times x to the 100th plus c. In the next example, we have to find the antiderivative of 1 over x to the 7th. Well, we can't just add 1 to this exponent and then divide by the new exponent, right? Because x to the 7th is in the denominator, right? We have to rewrite 1 over x to the 7th. And 1 over x to the 7th is the same as x to the minus 7th. Remember, the minus sign in the exponent means reciprocal. So x to the minus 7th is the same as 1 over x to the plus 7. And now you can see n is equal to -7 in this case. And so I'm finding the antiderivative. We add 1 to the exponent, divide by the new exponent. Well, -7 plus 1 is -6. So we have x to the -6 divided by -6. And then we add the arbitrary constant c. And x to the minus 6 over negative 6 is the same as minus 1/6 times x to the minus 6 plus c. And then lastly, in example 5, we have to find the antiderivative of square root of x. Well, you know we have to rewrite square root of x with a rational exponent. And square root of x is the same as x to the 1/2 power. So n is equal to 1/2 in this case. And now to find the antiderivative x to the 1/2 power, we add 1 to the exponent and we get 3/2, right? 1/2 plus 3/2, 1/2 plus 1 is equal to 3/2. And then we divide by 3/2. And then add the arbitrary constant c. Well, we got to simplify that a little bit. Dividing by 3/2 is the same as multiplying by 2/3. So this is equal to 2/3 times x to the 3/2 plus c. And we're done.